In this lesson, we will go over section 10.2. We're going to be comparing two population means. In the first section, 10.1, we compared two population proportions. It's very similar. We're going to do confidence intervals to estimate the population mean. So the first two examples that I will go over with you are constructing confidence interval and just kind of talking about what those intervals mean. And how they can be used to answer the question that we have. And from slide number 21, we're going to be conducting two sample t-tests for population mean, and those are the ones where we set up the null hypothesis and the alternative hypothesis, figuring out the p-value to either reject or fail to reject. So we'll do two examples of each, and that should be enough for comparing population means. All right, let's get started on this. So first, remember for population mean, we went over this in both chapter 8 and 9, how we may not have, and we very often do not know the population standard deviation. And in those cases, what did we do? Instead of using population standard deviation, we just use what was available for us. We use sample standard deviation, and by using those, we brought more errors or errors into our distribution or our estimates. So we had to go with, instead of Z test statistics, we had to use T test statistics, right? So for population mean, we're going to be using T confidence interval and T significance test. Okay, so the first example, I always did examples with summaries given, but I actually wanted to do an example with data, where they just really give us the raw data that they collected, and then we will go straight from those data. Okay, so constructing and interpreting confidence intervals to compare two population means, example 1, and we're going to be working with data this time. Let's take a look. A teaching assistant collected data from students in one of her classes to investigate whether study time per week, average number of hours, differed from students in the class who planned to go to graduate school and those who did not. So I guess, if you think about it, if someone is trying to go to graduate school, they may spend more hours spending, or I'm not sure, maybe I kind of understand why they may think it's different. I may think they may study more, but who knows? Maybe for some reason they may study less. Maybe they're doing, I'm not sure. But here's the idea. Maybe they're different. Maybe they're different, and that's what we're going to try to find, the difference between these two population means. The first population being people who are planning to go to grad school, and the other population, the second population, being the people who do not plan to go to grad school. So let's compare their means and see if there's any difference. Okay, so what you will get is, well, what I got in this study, in this example, is it's just the raw data, the data table. So if you take a look, graduate school, how many people are planning to go to grad school? Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You know what? I don't know. Oh, it's about like 20 something, like it's over 20. So what I already did was, I didn't really enter them by hand. What I was able to do is, this is from your My Math Lab homework. I clicked on the full data set, and then there was a button that sent this data set straight to StatLab. So you can do that, straight to StatCrunch, so that we can just work with it. But the big thing that I wanted you to notice is this. Notice how more people are planning to go to grad school, and less people are they're not planning to go to grad school, right? So the sample size, N1 and N2, they do not have to be equal. They don't have to be equal. And now, remember, when we do that's for significance test later, but when we did the degrees of freedom, that was simply N-1, right? We will see some crazy number for N-1, the degrees of freedom, when we do the significance t-test, because there's another way to calculate the more accurate degrees of freedom when the sample size is not the same, for these when we're working with these two samples. But what we're going to do is we're going to let StatCrunch do the test for us, and we're going to focus more on the interpretation so that we can use the technology and really try to answer the question in this chapter. So this is given data, and very often in the previous examples we were given the sample mean and sample standard deviation, those things. But if we are given data, just we're starting from a different point, but we should still be able to find the mean, standard deviation, standard error, everything. If we want to, we can do that, right? In fact, StatCrunch will just do the whole significance test or confidence interval for you, but I do want to kind of go over how to find the sample mean, standard deviation for each of the sample. Okay, so let's find the sample mean and standard deviation for students who plan to go to graduate school first, and we will do the same thing for students who do not plan to go to graduate school. Now remember how we find them. X bar and standard deviation. We can simply do column summary stat. So go to stat, click on summary stats, and click on columns. What we can do is we can select that we want graduate school to be our column, and then click on mean and standard deviation. Now I'm asking you to kind of try to find them because I know we're going to use StatCrunch to do the margin of error and everything, the standard error and everything, but if you are doing this by hand, the mean and standard deviation, mean and the sample standard deviation is what you need to calculate standard error. So just kind of wanted to review how you find them. So ta-da, if you click on compute, you will get that the mean is 11.42 hours and 43 hours, and the standard deviation is approximately 8 hours. Now let me double check. What are they talking about? Per day or per week? In 1 week, to study time per week. So people who plan to go to grad school, on average, study about 11 hours per week, and their standard deviation is about 8 hours. Now, you do the same thing for the group of people who do not plan to go to grad school, and I think I accidentally copied the same exact output table here, so that shouldn't be it. This should be slightly different. You notice how it says both graduate school and graduate school, so let me go ahead and delete that. And we can quickly figure that out together since we have this data set. So how about we do that together right now? Now, Min emailed me about the student course access ends in 4 days, and we don't want that because I want you to be able to use StatCrunch on your final exam. So I'm going to go ahead and take a look at the setting to make sure that you guys have access to StatCrunch until the final exam day. Okay? But that was a very, very good point because I don't want you to be taking this final exam without StatCrunch. Ooh. All right, so I'm in here. Let me go ahead and try to enter the numbers. The numbers that we have it's not too many, so I should be able to copy those down myself. So let's take a look. Try to make this go up a little bit. Sorry, I didn't. It looks like I screenshotted the wrong data set. So here, let me just do the no graduate school, and the numbers were 6, 8, 17, 6, 5, 13, 10, 10, 12, and 5. Okay, so I entered all the numbers for grad school. Thank goodness, that was a shorter list. So this is what you do. You go to Stat, Calculator, Summary Stat and Columns, and no grad school, and then we just want to find the mean and the standard deviation. I'm hitting the command button, and then once I hit compute, ta-da, where did you go? Here's the output table. So let me go ahead and screenshot this and then put it on the Google slide because I know you guys are taking notes as you are watching this lesson. So I have to fix this one real quick because I accidentally screenshotted the same exact output table. So let me go ahead and put this up here. Screenshot. All right, now that is good. Well, that's really what I did to find the mean and the standard deviation. And I think I'm really trying to model the problems that you're going to do for me on your exam and on your homework since we only have a couple days left. So the exam problems from this section are gonna be these problems, okay, with just different numbers. So real quick, let's compare just the samples that we have. People who plan to go to grad school study more on average, right? 11 hours. And people who tend to do not plan to go to grad school, they study less, about 9 hours on average. But then the standard deviation for this group is much smaller, about 4 hours per week, 4 hours. So by just looking at this, I shouldn't be. I think I have a little bit of feeling that maybe the people who go to grad school tend to study more, but with this bigger standard deviation and everything, I mean, it's not enough for us to just make a decision that hey, people who plan to go to grad school study more, or their average is significantly, or we should say, statistically significantly different. So guess what we're gonna do? Well, first, let's go ahead and interpret these values that we just found, mean and the standard deviation. The sample mean was higher for the students who plan to go to grad school. We saw that it was about 11 versus 9 hours. But the times were also much more variable for this group. Notice the standard deviations were compared to 8. That was much bigger than what? 4 hours, right? So that's the interpretation. Mean and the standard deviation kind of tells us that people who plan to go to grad school tend to study much more in average, in the sample average, but it's also much more varied, more variable for that group. So, well, anyways, let's go ahead and find the confidence interval to see if there's any difference. So what do we want to see? If there is difference, it shouldn't include this one specific number. Or in other words, if there's really no difference, their difference should be what? 0, right? So what we're going to do is we're going to do a 2-sample T confidence interval for the difference in these two population means, and see if that confidence interval captures 0. Because if it has 0, then really there's no difference, right? Because no difference means you subtract them, you get 0. So go ahead and take a look. Make sure your data is all in your columns. Click on Stat and T-stats. Why are we using T-stats? Because we do not know the population standard deviation for each of these groups. What we have is sample standard deviation for these two groups. So we're going to have to use T distribution to calculate. All right, go to T-stats, go to 2 samples, and click on with data this time. Not with summary, because we have data this time. And then let's go ahead and enter the samples in. Sample 1 is the graduate school data, and sample 2 is the no graduate school data. And click on, this time we're performing a confidence interval. We're constructing a confidence interval for mu1 minus mu2. Now take a look at that notation. Mu1 means the average for the first population. Mu2 is the population mean for the second population. So we're going to do graduate school average minus the no graduate school average. So I am thinking that our confidence interval may be positive, because what we saw was that people who plan to go to graduate school tend to have a higher average number of number of hours they study per week. So if you subtract big thing minus small thing, I mean we're expecting to kind of see a positive number. But if it includes 0, maybe then there's really no difference. At level 0.95, I'm going to just go ahead and create a 95% confidence interval. All right, compute it. Ta-da! So this is how we can just do a quick T confidence interval. Let's take a look at these. You see how they found the degrees of freedom for us, but it's not an integer, right? There's a little different formula, and I'm not really going to go over that one in Stat 1 class, but you may see that, and maybe in this grad level Stat class. But what we want to look is this. Take a look at the lower limit and the upper limit for me. Lower limit is down in negative 2.1, and upper limit is 6 about 7 hours. So this is how we can interpret this. Take a look. We are 95% confident that we will be able to capture the true population mean difference. And that true difference in these two population means are going to be anything in between negative 2 hours to 6 hours, the population mean is. So what number is included in this interval? This one is in the negative, this one is in the positive. What number is included in between any negative and a positive number? 0. So what does that mean? Well, yeah, I want to do confidence interval first. So the 95 confidence interval for mu1 minus mu2 is negative 2.1 to 6.6. I just rounded to the nearest tenth. So what's the interpretation? We are 95% confident that the difference in the mean study time per week between the two groups is between negative 2.1 hours and 6.6 hours. So here's the thing. Because that interval included 0 hours in the middle, and 0 means there's no difference, one cannot conclude that the population mean study time differs for the two groups. Okay, so even though it looks like the people who plan to go to grad school tend to study more by just looking at our sample, because it was 11 versus 9, that difference was not big enough for us to say, hey, there is a statistical significant difference between these two group averages. Okay, so one more thing that I wanted to kind of include though, the standard error. It found it for us, and I included it because your homework problem was asking for it. Standard error, you do know the formula for it. It was what? Sample standard deviation divided by square root of n, right? And here's the thing then, which n did they use, right? So I'm not really gonna go into the formula for two sample standard error. What I'm gonna do is just, you know how to find it. You know how to find it using technology. Let's interpret it. What does that 2.14 mean? The interpretation is this. A further random sample of these sizes, the sample sizes were different, but if you keep the same sample size for population 1, sample size 1 and sample size 2, were obtained from these populations, then the difference between sample means would vary, right? Because one sample is not going to be exactly the same as the other sample. Of course, there's going to be some variation, but the standard deviation of these varied values for x bar 1 minus, well, x1 bar minus x2 bar, if you subtract the sample means, they would have a standard deviation about 2.14. So the standard error is talking about the standard deviation of the difference in sample means if you continue to take the sample size, or the same size samples from these two populations. So that's what they're talking about. So I just wanted to kind of include that. But since we found the confidence interval and made our conclusion that we cannot conclude that the population mean study time differs for these two groups, I mean, we are done with our job. So we're going to move on. Now let's take a look at another one. But this time, I'm going to do one with summary. Okay, so the data is when they just give you a long list of data to just go from the scratch. But if we have summary, we just have to enter the summary and use those summaries to find the confidence interval. Let's take a look. A study of bulimia amongst college women studied the connection between childhood sexual abuse and measure of family cohesion. Oh, I did not know that. So they have a study like that. Okay. Alright, bulimia and sexual abuse in childhood and a measure of family cohesion. Okay. The higher the score, the greater the cohesion. Okay. So let's take a look what they gave us. The sample mean on the family cohesion scale was 1.9 for 11 sexually abused students. And take a look, in the parentheses, I'm giving S equals 1.7. What does that mean, S? The sample standard deviation for the sexually abused student sample of these 11 students, okay? Now, look at that sample size, and we'll talk about it. It's pretty small, 11. It's not that big. All right, and 5.1, this is the sample mean on the family cohesion scale for 19 non-abused students. And the sample standard deviation for that group was 3.3. Now notice the sample size is also different. N1 is 11 and N2 is 19. They don't have to be the same. So just because you found 11 sexually abused students, you don't have to go out and find the exact number, 11 so they don't have to be the same. But we got summary. The mean for sample 1 is 1.9. Sample size is 11. And standard deviation for that sample is 1.7. And these three numbers are for the sample 2. So let's use this summary. But just wanted to mention that little s means sample standard deviation. Okay? Alright, so this time we're going to say that we have summary. Okay, let's construct a T confidence interval for population mean. Two sample, and we're trying to find the difference We're trying to estimate where is that true population average difference. So again, remember, we're trying to see if the 0 is included in this interval, right? So go to Stat, T-Stat, and click on To Sample. And click on Summary because we were given Summary this time. Now, I enter just these values in there, and these are just from that word problem for the information they gave us. The sample mean was 1.9. The standard deviation for that sample was 1.7, and sample size was 11. There were 11 sexually abused college students in that first sample. Now the other one, the sample mean, what was the score on the cohesion scale, was 5.1 for that group. And sample standard deviation was 3.3, and sample size was 19. So you gotta enter these 6 numbers in there for StatCrunch to find the confidence interval for you. And we are creating a confidence interval to estimate the difference between mu1 and mu2. The true population average minus the true population average for the second group. And we're just going to do a 95%. And if you want to be more sure, I guess you can do 98%. But then as you are increasing your level, you know what will happen to the confidence interval, right? If you increase the level, if you want to be sure, I mean, the interval will get wider and wider, right? If you want to be sure. All right, so 95 is standard. So we're going to go with 95. And ta-da, you click compute, and there you go. Now the sample difference, I mean, they found the sample difference for us. It was just 3.2, but that was negative. Degrees of freedom looks a little crazy, but what we want to find is the lower limit and the upper limit. Let's take a look at this confidence interval they found for us. Well, we found for ourselves, right, using technology. The lower limit is -5, and upper limit is -1. Now, what number is not included in this interval? This is completely under 0, right? So 0 is like somewhere over to the right side of this upper limit. So what we got is this. We got a confidence interval that is completely negative. What we can infer is that the population average for the first group is going to be smaller. It's smaller than the population average for the second group, because we did the first group minus the second group. We did small number minus the big number. That's how we got a negative interval. So, and how sure are we? About 95% confident. So, here we go. I'll come back to the standard error, but let me go ahead and first interpret this 95% confidence interval for mu1 minus mu2. That interval was from -5.07 to -1.33. The values in the 95% confidence intervals are less than 0. This interval is completely below 0. What does that mean? That implies that the population mean for sexually abused student is less than the population mean for the non-abused students. Because if you do small thing minus big thing, well, you get negative, and we are 95% confident that this is true. So what about that standard error of 0.91? That's pretty small, right? That's pretty small. If further random samples of these sizes were obtained from these populations, assuming that our sample was very random and independent, the difference between the sample size, sample means would vary, right? Because no sample is the same. No sample is the same, and they're all going to have different sample mean, unless you sample the exact same group of people again. But they're going to be somewhere close, right? They're not going to be like very different. And that difference, that variation, can be measured by the standard error. The standard deviation of these values for the sample one, the sample average from the first group minus the sample average from the second group would be equal to about 0.9143. That's what this standard error is saying. That is talking about the standard deviation of the difference between sample means if we try to get more samples of that same size. Okay? So we just went over 2 examples of confidence interval. Okay, completely using technology, focusing more on the interpretation and answering the questions. And the questions were, is there really a statistical significance difference between these two population averages? And one did, the other one didn't. And that depended on whether the interval includes 0 or not, right? Now, let's do a significance test. And I kind of like confidence interval better because even if it didn't, the confidence interval, what's better about it, it gives us an estimated range of the true population difference, right? It gives from, hey, it's going to be probably from this number to that number, and we're 95% confident. Now, we're about to do the significance test, and all we're going to be able to do is either we reject or we fail to reject that there is a difference. So I kind of like the confidence interval much more better, but we're still going to do some significance tests, okay? So we're going to do same type of problems, trying to see whether there is a difference between two population averages in using t-test, because we do not know the population standard deviation, okay? All right, let's start. Conducting a significance test to compare two population means that example 1, and this time we have a summary. So when you're given a summary problem, you just have to look for 3 things. First, you need the average, you need sample standard deviation, and you need the sample size. Those are the 3 things you need for each of those of the samples that you're given. All right, a recent study evaluated how addictive teenagers become to nicotine once they start smoking. The response variable was the number of yes answers on a questionnaire called a Hooked on Nicotine Checklist. H-O-N-C. So now I almost thought like this will be a good proportion problem, but now this is the number of yes answers on a questionnaire, right? Now, unless this questionnaire is infinitely long, maybe let's suppose that there are like 10 questions, and someone will answer all 10 yes, and none of them, if they don't say yes for on none of them, then it will be like 0. So it ranges, but it's not a proportion. It's really the average number of yes answers on this questionnaire. So okay, definitely a quantitative variable. We should be able to continue with this and just kind of checking the assumption, right? And somewhere they should have mentioned random. We'll keep reading. Or if not, we will assume they did the right thing, and then we will continue with this test. All right, a subject was called a monthly smoker if he or she had smoked cigarettes over an extended period of time. Okay. The 77 female monthly smokers had a mean HONC score of 5.3. So they answered about 5.3. It can be an average, right? Because average can be a decimal. About like 5.3 yes answers on this questionnaire. And look, the standard deviation for that sample was 3.7. And 72 male monthly smokers had a mean HONC score of 3.9. Now notice this number is a little bit smaller than the number of scores from female smokers, but could that difference be big enough so that we can say this is statistically significantly different? Well, we'll see. And the standard deviation for that group was 3.6. They're very similar standard deviation, but now the very last sentence. Highlight this because this is them giving you the summary. These are 6 numbers that we're going to be able to enter to find the, we're not finding the confidence interval this time. We're actually going to perform a significance test. But the last sentence is what you need. They gave you the summary right there. All right, let's go ahead and go to stat, t-stat, and to sample with summary. To sample with summary, because we are given summary this time, right? Now take a look at the numbers that I entered. For female, the sample mean, the number of yes answers on this questionnaire was 5.3 with standard deviation of 3.7. And they how many did they do? They did 77 female students, right? Same thing, similar. Sample mean for the male students, they answered about 3.9 yes answers. And the standard deviation was 3.6. It was a slightly smaller sample size, 72 students for the males. Now, not the confidence interval, but this time perform hypothesis test for mu1 minus mu2. We are going to assume, and for our class, we're just going to always set null hypothesis as the difference is equal to 0. Difference equals to 0 means what? There's no difference. They're about the same. That's what we're trying to test. That's what I guess that's what we're trying to reject, right? And I'm not really gonna look at the sample mean. I just just go with, there's no reason to believe in the context of the problem that women will have a higher mean, the sample average, or the average all over in population. So we're just going to go ahead and do a two-sided test. So go ahead and say mu1 minus mu2 does not equal to 0. And very often you are going to conduct these two-sided tests unless you read a problem and there is a very good reason to believe that we should probably do one-sided test. But there wasn't really, they didn't really type that in the problem, right? So we're just going to go ahead and do a two-sided test and hit compute. Ta-da! Here we go. So the sample difference came out to be positive because we noticed the woman average was slightly higher. But what we care about is the t-stat and the p-value, right? They gave you the test statistics, which is about 2.34. This is positive. So we should be looking at the right tail probability of that 2.34 on a t-distribution who has a standard, degrees of freedom of 146.76. We can use t-distribution calculator to find the probability, but we will get the same p-value, 0.02. So what we're going to do is we're going to just focus on the interpretation using these numbers, because these numbers tell us something, and it's our job to interpret this so that we can answer the question that we want to in a language that everybody will understand. So let's see, what do these numbers mean? Since the p-value, take a look at the p-value for me, about 0.02. 0.02, this is like 2%. Now what does that mean? That p-value is less than 0.05, and 0.05 is the most popular significance level. Okay, we're going to reject the null because p-value is smaller than 0.05. When p is less than alpha, reject the null. And the null was stating there was no difference, right? So if you reject there's no difference, then you go ahead and believe the alternative. Oh, there is a difference. Conclude that the mean HONC for female monthly smokers is different from the mean HONC score for male monthly smokers. So that's what we can conclude by looking at the small p-value, because we rejected the null hypothesis. Okay. Now remember. Now there's an additional question that I typed up here. Do you think that the HONC scores were approximately normal for each gender? Now that's a good question, right? Why or why not? Does this affect the validity of the analysis? What were the HONC scores for each of these genders? The sample mean was less than 2 standard deviation above the lowest possible score 0. So the population cannot be approximately normal, but if it's not normal, can we still say this significance test that we did is valid? I mean, can we do that? Well, it does not affect the validity of the analysis since the sample sizes are large. Or was the sample size large? Oh yes, take a look at sample size. 77 female students and 72 male monthly smokers. So we had well over 30 for each of these groups. So because of the big sample size, using the central limit theorem, we can still approximate that the sampling distribution of these differences are going to be approximately normal. So okay, that works. Okay. Let's do the very last example. Let's see if I'm still recording. Sometimes I'm recording, thinking that I'm recording, and I'm not recording. All right, it's about 34 minutes now. I think I have one more last example, and that should be it. Okay. Conducting a significance test to compare two population means, example number 2. This time we're given summary again. But I think they gave it to us in a slightly easier way to see. The summary statistic in the table, they organized it in a table for us. For comparison of females and males on the number of hours a day the subject watched TV. Is there a good reason for us to believe females or males, one of them, watch more TV? Not really, right? Not really. Let's take a look. The sample they collected, wow, look at that big sample size. The female, 674 of them, they watch about like 3.08. And the male, out of 628, they sampled about 2.69 hours per day that they watched TV. Now, that difference doesn't really look too big to me, really. Looks like a female watch about like 1 more hour. Um, well, but we never know until we actually do some statistics to see if there's a significance difference. So let's go ahead and do that. I love how they got everything labeled for us. Sample size, the sample mean, and standard deviation. Because these are the 6 numbers that we need to enter. I'll set up the hypothesis first though. Okay, let's do that. Significance test, you need 2 hypotheses, right? You need the null hypothesis, which will make it to be just mu1 minus mu2 equals 0, indicating there's no difference. So set up that the null hypothesis is that mu1 minus mu2, there's really no difference between these 2 averages. And I think that's probably it. I mean, just by looking at the sample, I don't think there's a big difference. But who knows? We never know. We're going to go try. All right. What about the alternative? There's no reason for me to believe females watch more TV or males watch more TV, unless it's I don't know, like football season, who knows? So I'm just gonna go ahead and do a safe that they are not equal to each other, that they're just different. Okay. So if I reject the null, then I'm gonna go believe that they're really different. If I fail to reject the null, I'm just gonna go ahead and state that hey, maybe there's really no difference. Okay. So we set up these hypotheses. 2-sided test, and just kind of wanted to include other ways of writing it. The first one, when I said mu1 minus mu2 equals 0, that means they're equal to each other, right? There's no difference, therefore they are the same. Well, if the difference is not 0, then they're gonna be different. So you may see different like stat problem, like if you're taking I don't know, if you're taking more stat classes, and maybe that in that class you may like to write it this way instead of saying the difference, but they're really saying the same thing, right? Okay, let's go ahead and use StatCrunch to conduct all parts of the significance test, and this is how you will really do in real life. You don't really get a piece of paper to find the t-test statistics, distribution table. You really use technology, Minitab, Excel, StatCrunch, SPSS. I mean, if you're gonna study stat more, I mean, some of these professors or some of these like jobs, I know in like biostat field more than use SPSS, different program, but there are gonna be technologies that you're going to use to conduct these significance tests. And in our class, in our undergrad class, we're going to be using StatCrunch. So go to tstat, 2sample, and click on summary and enter all those good summary they gave us. I'll just double checking if I entered everything correctly. This was a table that they gave us. Mean is 3.08, standard deviation is 2.59, and sample size is correct. Now, as you guys are watching this, if you notice anything wrong that I typed up, just let me know. Looks good, looks good. All 6 numbers are good. We're going to conduct a hypothesis test for their difference, population average difference. And then the null, we set it to be that there's no difference. And then the alternative is there is a difference, that the difference is not equal to 0. Hit compute. Ta-da! Now, my eye automatically went to what value? P-value. Guys, look. When I first looked at that, those average difference, like it was like 3 hours versus 2 hours, I was like, there's really not a big difference over there. That's what I thought. But take a look. Look at that big, small p-value. It's small, but it's strong. All right. Small p-values are strong evidence against the null hypothesis. We have a very strong evidence to believe that the true population difference between female and male is actually different. Okay. All right. So let's interpret this p-value of 0.005, which is less than 1%. What does that mean? Since the p-value is less than our common alpha level of 0.05, we're going to reject the null hypothesis. Conclude that the mean number of hours a day female watch TV is different from the mean number of hours a day, not hours per day, males watch TV. Now, what I want is this. This significance test, the only thing that it gave us is this. Hey, they're different. But now, you know what I'm wondering? If they're different, how different are they? Do females watch more or males watch more? So if I were you, I would go in and do a construct a confidence interval to see if that interval is completely above 0 or below 0, because we just did a two-sided test. The result better match the result that we get from what? The confidence interval at 95% confidence level, right? Maybe I did. Ooh, look at that. If you were to construct a 95% confidence interval comparing the means, would it contain 0? What a beautiful question, don't you think? Because we just rejected, hey, they're different. They're going to be different. So if they're different, will we capture that 0, meaning no difference, in our 95% confidence interval? Since the test provides sufficient evidence to reject the null hypothesis, 0, no difference, 0 means no difference, guys, is not a plausible value for the difference between the population mean. So a 95% confidence interval comparing the mean would not contain 0. Guess what that 0 is? That is in the right. I think it's going to be in the right side because females were a higher number. I actually want to what? Do it. Yeah, why not? Why don't I do it, guys? What I want to see is this. I want to see my confidence interval completely above 0. But that really concludes this lesson. So if you want to stop, that's okay. But you are about to see me just doing some extra, because I wonder about this. All right, I'm back to my stat crunch. And this was stat, summary stat, stat, T-stat 2 sample with summary. And let me go ahead and enter these numbers in. Hold on. What were the numbers? The numbers were 3.08, 2.59, sample size 674, and 2.69, and 2.46, and 628. With such a small p-value, I am pretty sure the confidence interval will be completely above 0. But who knows? Let's take a look. I will do a confidence interval for 0.95, and the result, what we know is it better not include 0, because significance test just rejected that null, that there is no difference. So let's go ahead and compute. Look at that confidence interval. I love it. I'm going to go ahead and screenshot it for some people. Because I know some of you are wondering about this too, just like I am. I'll go ahead and just include that real quick. And let's talk about this, and then we'll stop. Look at that confidence interval. 0.11 to 0.66. Completely above 0, not including 0. So what we can say is this. The mean of population 1 is probably at 95% confidence, we know, that is greater than the mean of population 2, because how do we get a positive number if you subtract big number minus a small number, right? I mean, can we be wrong though? I mean, we talked about what? 9.4, we talked about errors, right? Well, there is a 5% chance that we may be wrong, may be making a type 1 error, right? But, well, that's just 5%. So, I think this is awesome. This was so fun. These are the actual 4 problems that you're going to see on your homework. And these are the 4 problems that, not probably all 4, but maybe I'll pick like 2 and put it on your last exam 3. We'll call it final exam. Since, toward the end of the semester, we didn't exactly have too many time to kind of do the review and everything. I'm just going to keep it very similar. And if you're noticing that I kind of go over the homework problem that you are doing for me, because they are all great problems. But if you still need help, just let me know. We can have Zoom office hours. And I know this class ends Friday the what? Friday the 8th. Yeah, that's it. So I have about a week left. But I will be back with the very last lesson, 10.4, very short, and that's it for our class. Okay? See you later.